Our next presentation is entitled SELEN, Semantic ELicitation ENvironment, and our presenter is Manuel Fiorelli, who is a research fellow at Tor Vergata University of Rome in Italy.
Can you hear me? Thank you for the introduction. Today, I'll give you a brief preview of SELEN, our brand new semantic elicitation environment. To start, I'll give you some considerations about the role of semantics in digital archives, noting in particular how thesauri and other knowledge organization systems support information retrieval by enabling a number of features such as semantic browsing and search, query expansion, federated search, and much more. To give you a more concrete example, let us focus on this artificially generated guy who is seeking relevant legislation on the EURLETS portal of the of the European Union legislation. Since legal acts have been indexed with concepts in Eurovoc, in the Eurovoc thesaurus, this guy can be more effective by first browsing the conceptual backbone of Eurovoc, identifying the concept of interest, and only in the end ask the system to return all and only the documents that are about that specific concept, regardless of whether the label of that concept literally occurs within the document itself. So being much more effective than a plain text search. In the context of semantic search, they summarize this saying, search for entities, not for string. Moving forward, at this point, it should be as no surprise that there is a great interest in developing and maintaining such reference data. And surprisingly, the Publication Office has been managing the development of VocBench 3, an open source, free-to-use collaborative platform for the development and maintenance of ontologies, thesauri, lexicons, and datasets in general, conforming to the main standards of the Semantic Web and the linked open data. For those who are interested, here there is a link where to find additional information. Moving along, over the years, VocBench has established as a reference platform in its own area of interest, supporting different types of knowledge organization system, as I mentioned, and also being very flexible, able to scale down, for example, to individual developers working solo on their own desktops, while also being able to scale up to very large distributed teams that collaborate remotely, possibly benefiting from structured collaboration workflows that enable higher quality by having certain people proposing changes, which are then vetted and, if deemed suitable, approved and made persistent by other people with specific capabilities. Overall, VocBench focuses on manual editing, although there are batch import capabilities both from Excel files and other tabular data formats, as well as from relational database. However, in these recent times, it is becoming even more apparent the urgent need to support a number of use cases related to the combined use of reference data and document corpora to support the development of reference data or to support their application. These use cases outside the scope of VocBench are precisely the scope of this new platform called SELEN, which stands again for Semantic ELicitation ENvironment. By discussing with our stakeholders, we specified this huge family into 4 main areas of interest. Document tagging is about a multi-label classification task where you have documents and you have to uncover one or more concepts that capture their meaning. This is precisely the task underlying the EURLES portal that we have discussed before. Then there is thesaurus ontologies evolution, where dually you analyze the available documents to uncover new conceptual or terminological knowledge to introduce into the reference data. Semantic annotation, not to be confused with document tagging, because now we are interested in recognizing the occurrences of concepts inside the document rather than classifying all documents as coarse-grained entities. Finally, knowledge acquisition is similar to the thesaurus ontology evolution, but it differs in that now we are interested into eliciting assertional knowledge, say facts, possibly using a vocabulary aligned to existing reference data. SELEN is a standalone system which can be accessed through a REST API, as we will see. And its main reason is to address these use cases that fall outside the scope of VocBench. However, we should not underestimate the benefits that could be obtained if it is VocBench to invoke SELEN, to use its capability to streamline the development workflow, complementing manual editing capabilities already built in inside VocBench with new AI-based capabilities that could be introduced by means of SELEN. As you can see, the platform has not been released yet, but we are approaching the first release, for sure, within the end of this year. Therefore, as I mentioned at the beginning, this presentation will be most a sort of preview, hoping that you will see the final announcement and the more advanced presentation in the near future. Accordingly, my focus will be a description of the scope of the platform. We have already done part of that. Describe its functionalities, and then provide some consideration about conceptual and technical aspects, as well as anticipating expected benefits. We have already seen our functional requirements in terms of the 4 areas we have described before. But now I highlight the fact that during this first release, we will mostly focus on document tagging, leaving the others for further iterations, which signifies that this platform will have a long evolution and will be maintained for a long time. Okay. Moving to non-functional requirements, I just list 3 of them, the main ones: availability, usability, and maintainability. And I want to stress that an important part of the design of this platform has been the selection of suitable dependencies for 2 important aspects: the underlying framework for orchestrating text engineering activities, and the tool for interfacing with heterogeneous documents. It is not really important if you don't know what Apache Vim and Apache Tick are. They are just notable examples of these categories of software. The most important takeaway, in my opinion, is the methodology we followed by ensuring a suitable choice, making it after a survey of existing solutions which have been compared in terms of general criteria, such as licensing and programming language, as well as specific ones which were different for the first category and the second category of dependencies. Having described our requirements, this is a high-level picture of the architecture that we came up with. As you can see, SELEN acts as a sort of orchestrator on top of which you deploy the intelligence, the algorithm, and then the platform will connect it to reference data and document corpora that are hosted respectively on diverse dataset origins and file manager. The output can be accessed by a variety of tools, potentially any application that can consume our API, but again, I put VocBench as a reminder of the possibilities that can be unlocked by the integration of these two systems. As I imagine you are hungry for details, I exploded the high-level picture by developing this 3D stack, all in PowerPoint, in which I try to summarize the main aspects of the architecture. At the bottom, we find Java. Maybe it would have been more correct to say the JVM, Java Virtual Machine, just to say which is the underlying technology we use. On top of that, we use Spring Boot, which is quite a common choice in this environment. But then we deployed on top of it PF4J, which stands for Plugin Framework for Java. You will understand the necessity of this ingredient in a moment, while I'll discuss SELEN. Indeed, SELEN is not a monolith. It is not a closed system which implements a definite set of algorithms. Even worse, on a specific dataset or document corpus. It is instead an orchestrator based on an open architecture, which allows you to plug different algorithms that implement a certain use case, each associated with, probably you can't see, with an extension point that defines the interface between SELEN and implementation of the algorithm. For example, for document tagging, we expect the implementation to be able to take some text and produce some tags. Then SELEN will connect the implementation with the dataset origin and the file manager. As you can see, each extension point can be implemented in different manners. For example, for the file manager, we have both an implementation for the local file system and an implementation for the KMIS protocol, which allows you to connect, for example, to Alfresco. As I repeated much times, we have a REST API to connect to be accessed by external system. A final note on Data Manager, which is alike the File Manager, but instead of managing files, it is used to manage the internal state of the platform to potentially offload to external replicated distributed stores, which is important for cloud deployments. During the end of the project, we concluded the implementation for UNIF as an example of document tagger, and then we are evaluating its performance on a document set of interest for the publication office, where we have a heterogeneous document tagged with Eurovoc concepts. Unlike existing datasets such as URLets 57K, multi-URLets, and Kevlar, which instead focus on legal documents published on URLs. One interesting thing is to evaluate whether there is any difference in performance between these two use cases. Let me conclude by discussing again the importance of the openness, which allows you to plug different implementation for different exigencies. Say, do I have the hardware to execute an LLM, or I prefer a more resource-conserving algorithms based on simple techniques? Again, we can both integrate SELEN into existing systems, say VocBench, as well as integrating existing system, say ANIF, which is a subject indexing tool that we integrated as an implementation of the dog tagging use case. This integration has several benefits, in particular providing orchestration capabilities, connecting the tool with the document stores, and potential with the user interface within VocBench. We ensure high availability by being cloud native, as anticipated, while usability is achieved through user interfaces for the end users, whereas maintainability is achieved by a combination of documentation, consisting coding standards, modularity, and so on, for the developers. The last slide, the tool has not been released yet, so I can say we achieved this. What I can say are the prospective benefits, the intended benefits, which are ensure to support scenarios where we want to apply reference material, say to tag or annotate content, as well as to streamline the development workflow by introducing automation in VocBench. As usual, automation means greater coverage and timeliness by automating hard work, and at the same time relieving humans from a lot of work, taking, however, them in the loop, the so-called human-in-the-loop AI, which should guarantee high precision by having machine making the hard work, with humans effectively providing the last fixes and touches. Thank you for your attention. I hope to have been within the bounds.
Thanks very much. First question from Slido is from Marcel. For production deployments of software platforms, I see a lot of effort for managing vulnerabilities. Do open source projects like SELEN have the bandwidth to manage such aspects in a timely manner?
That's a good question. Indeed, we put a lot of emphasis in security scanning. We have security scanners that are executed on this code base, and we have a requirement, not a passion form, but a requirement to fix them in a timely manner. Obviously, priorities with the prioritization, say, if a vulnerability has a low impact, is less critical, will be fixed with less priority. If instead it is a high critical priority, we will try to fix as soon as possible. Obviously, we might not have the same time to reaction as a bigger corporation, but I think that we managed to fix them, at least in a reasonable time frame.
Thanks very much.